Hi again, this is lesson 1-5 continued, and we are now going to be looking at circumference and diameter and the radius of a circle and the area of a circle. I think, yes, we are going to be doing that. So we are on page 37. All right, we need to talk about several things with a circle. Let me make sure that you are seeing what I'm able to draw up here. Yeah, okay. So a diameter runs from one side of the circle to the other through the center of the circle. It could also run at a different angle. We could go down. We can have an infinite number of diameters in these circles. They can be in any orientation through the circle. But I'm going to use this flat one right here, and we call it diameter. That's our diameter. So I'm hoping that you might already know that half of a diameter is called the radius. It's really important that we know both of these terms because we're going to use them in our formulas. So we have radius, we have diameter. If you need to pause the video at any point to write words down or to kind of focus on what I'm saying, please do so. But we have our diameter, which is the whole distance across the circle from side to side through the center. And then we have our radius, which is exactly half of the diameter. It runs from the center of the circle to one edge of the circle. Alrighty, now let's look at a couple of other things. The other thing we need to talk about is circumference. The circumference, C for circumference, the circumference is the distance around the circle. It's like the perimeter of the rectangle. It's the distance around the circle. If we were able to take the line that is the outside of the circle and unroll it or unwrap it, it would fall into this flat line that is our circumference. So circumference is the distance around the circle. All right, so now we have formulas that we need to talk about. We have a formula for circumference. It is pi d. That's my favorite. There's another variation on it that is 2 pi r. These are the same formulas. And the reason they are is because 2 r's, look at this right here. This is an r from center point of circle to edge. This is another r on the other side from center point of circle to the edge. So an r plus an r makes a d, or a radius plus a radius makes a diameter. So we can say pi, this is the sign for pi, times d, or we can say pi times 2 radii, or 2 times pi times r. So you have those two choices for finding circumference. We also have another formula, which is for area of the circle, finding the inside, and that is pi r squared. All right, we will do a little bit of practice with those, but let's talk about something first. The ratio of a circle's circumference, so this distance around, to its diameter is represented by the Greek letter pi. So the ratio would be a fractional relationship. The ratio of the circumference, remember that's the distance around, I'm going to write it like this, circumference to diameter equals pi. And I bet you already know what pi stands for. Pi stands for 22/7. That means that that is a universal ratio representing the ratio of circumference to diameter. And when you do the math on 32/7, a fraction is always a division problem that we can do. So 22 divided by 7 equals 3.14, although that number continues on and on and on. Now, a couple of things I need to tell you about that is when you're doing some of this work on your calculator, you may use 3.14 and literally put that in manually. Or I would encourage you to use the pi button on your calculator. And let me grab my calculator and see if I can show you one. Well, if I could find my calculator, I could show you. I'm not going to be able to show you that right now. I apologize. you are looking for a button that looks like this, and you are often going to have to use a little shift key to get to it. So it may be a second option above the normal button. All right, so I would encourage you to use that whenever possible. It's going to give you a more exact answer and an answer that's more likely to match the answer in the back of the book. The second thing I'm going to tell you is that sometimes your homework is going to ask you to leave your answer in terms of pi. When you have to leave it in terms of pi, that means you don't do all the math on it. You don't actually multiply it by 3.14. If your answer was going to be 2 times pi, and you were about to do the math on that, but it said to leave it in terms of pi, then this would actually be the final answer because you left pi in the answer. All right, let's look ahead. Give me just a minute to see where we are. All right, let's practice a couple of problems. We have a circle. Let me erase some of this. We have a circle with a radius of 3 centimeters. Circle, radius, 3 centimeters. All right, now we can do our math. Let's see, Mrs. Brendel, do you have a calculator over there that I can borrow? Okay. Let me see if I can find that pi on her calculator. Yes, right here. On her calculator, above the arrow is a blue pi sign. So I'm assuming what she has to do is press the blue second and then the arrow to get the blue pi sign to do the math on it. All right, let's do the math on this. Let's find the circumference of a circle with a radius of 3 centimeters. So I like to use this formula. I'm going to say pi times d. Of course, this is not a d, this is a radius. So what would my actual diameter be if it went all the way across? It would be 6. So I would say circumference equals pi times 6. I would do the math on the calculator. I would say 6, and then the button for pi. And the answer should be 18.8. Circumference equals 18.8. This is distance around, not area, so the answer is simply centimeters. Okay, now let's try it with the 2 pi r formula, just so you see that that comes out the same. So that's the same as pi d, but it's 2 times pi times the radius. So you're using 2 radii instead of the diameter. So 2 times the radius of 3 is going to be 6. And we're back to 6 pi, which is where we were last time, so our answer is going to be identical. Okay, now let's do area. Our area formula, remember, see if you can say it in your head before I write it. Pi r squared. So area equals pi times the radius of 3 centimeters squared. We're going to square that 3, and it's going to equal 9 pi. And then when we do the math on that, it is 28.3 centimeters. And of course it's squared because we squared 3 centimeters times 3 centimeters. So that's centimeters squared. Okay, hopefully that helps y'all with using your formulas to solve for perimeter, area with several different shapes, rectangles, triangles, and squares, but also circumference and area with circles. There's one other word problem that I want us to go back and look at, and then we will be done. This is the word problem at the top of page 35. This is example 2, the crafts application. The Texas, and actually I'm just going to have you look along in your book with me at this one. The Texas Treasures quilt block includes 24 purple triangles. The base and the height of each triangle are about 3 inches. Find the approximate amount of fabric used to make 24 triangles. So you can see a picture of that quilt, and I'm going to draw you a picture of one triangle in it. Eyes up on the board for a minute. It said the base is 3 of each triangle and the height is 3 of each triangle, and it said inches. Remember, 2 little marks, and they want us to know how much it will take to make 24 triangles, or to make the quilt. So we need to use the area, find the area of each of these triangles, and then multiply it by 24 triangles. So area equals 1/2 base times height, or base times height divided by 2. Area equals base times height, 3 times 3 is 9. Now we've got to divide that by 2. So the area of each triangle is 4.5 centimeters squared. It was centimeters times centimeters. And now for the area of the whole quilt, or the area of fabric used to make the whole quilt, we've got to say 4.5 centimeters squared needed for every triangle, and multiply it by how many triangles? 24 triangles. And when we do the math on that, we get 108 inches squared, which means I was telling you the problem was in centimeters squared, but it was actually in inches. I don't know where along the path I jumped to centimeters. I apologize. We're dealing with inches, which is why I drew inches. All right. I think that's it. I hope that your homework goes well, and I will look forward to seeing you in the next class.